Hello Calculus 1 students. Today in this video clip, I'm gonna go over Appendix D about trigonometry. In this section, I will go over some basic trig functions which I believe will be very helpful for you guys to learn Calculus 1 later on. So let's start with angles. Alright. We have two units to measure an angle: radian and degree. I claim that later on we're going to use mostly radian rather than degree, but we obviously learn degree first, so we're going to learn them both. Radian is a unit and calculated with the conversion is this. 1 pi of radians is 180 degree, and obviously 2 pi is 360 degree, which is the whole circle. And of course, you can calculate and convert back and forth between radian and degree proportionally. Okay. And then say you have a circle with some basic formulas. All right. What if you only have a part of a circle, radius say r, and center right here at say O is the center, and then the angle is say theta. And we can calculate this arc length right here. Let's call the arc length S. Then S is going to be equal to theta times r. And for the whole circle, we're going to call it the circumference. The circumference C is going to be 2 pi r, because 2 pi is the angle of the whole circle. So if you have an angle theta, just simply take theta times the radius r. Theta is in radian, that's the unit, right? Then multiply, you have the arc length, okay? And circle, the whole thing, circumference, 2 pi r. About the area of this slice of pizza right here is, let's call it the area, is 1/2 theta r squared. And of course the area of the entire circle is 1/2 of 2 pi times r squared. Theta is the angle of that slice, and 2 pi is the angle of the entire circle. And of course, we can simplify something. The 2 going to cancel out, which is pi r squared. Now you have the formula for the area of the entire circle. Okay. Now let's talk about the 6 basic trig functions. See how we define them and how we figure out the trig identity. Okay, let's start with the right triangle. Alright, this is the angle of 90 degree. This is the hypotenuse because C. This side is say A, side is B. Well, the very first thing that comes up in my mind whenever we talk about right triangle is the very famous theorem called the Pythagorean theorem. Say what? The hypotenuse square is equal to the sum of the square of two sides. So A squared plus B squared is equal to C squared. Pythagorean theorem. Okay, now it's time to recall the 6 basic trig functions. Let's start with sine. Alright, so let's call this angle theta. Okay? So sine of theta is, as we learned before, opposite over hypotenuse, which is B over C. The second trig function is cosine theta, is adjacent over hypotenuse. It's going to be A over C. And then tangent of theta, which is opposite over adjacent, B over A. And now we have the first 3. In class, most of the time we're going to learn only that 3. Not good enough for us to work with most of the problems. Okay, but take a look at this. Sine is what? B over C. Cosine is 8 over C. Now what if you take sine over cosine? And that C on the bottom, going to cancel out, you got B over A. So more or less, actually tangent theta is really equal to sine theta over cosine theta. Okay? Those 3, almost everything. The fourth one is cotangent theta. And cotangent theta is the reciprocal of tangent. So instead of b over a in here, now it becomes a over b. So cotangent of the angle theta is adjacent over opposite. Of course, reciprocal of sine over cosine is cosine of theta over sine theta. Okay? And then the fifth one is secant theta. Secant is the reciprocal of cosine. So if cosine is a over c, so secant is going to be c over a. So reciprocal, 1 over cosine theta. Okay? And similarly, the last one you can guess, cosecant theta. It's going to be the reciprocal of sine theta. It's going to be c over b, which is 1 over sine theta. And those are the 6 basic trig functions that should keep in your pocket when you start our Calculus 1 course. Alright, now it's time to derive some fundamental trig identities based on the trig function, the 6 of the trig functions that we have today. Let's start with the Pythagorean theorem in here. C squared equal to a squared plus b squared, right? What if I divide both sides by c squared? I got divide by c squared, c squared, c squared. I got 1 is equal to a over c squared plus b over c squared. And you know what a over c is? A over c is cosine. And b over c is sine. So the first and the most popular trig, in my opinion, is 1 equal to cosine squared theta plus sine squared theta. Okay? You guys are going to use this one a lot. So far, so good. Next, let's talk about a couple more trig identity. Let me erase this to get more room to write on. Before moving on to the trig identity, let me come back to the definition of the trig function, sine, cosine, secant, cosecant, tangent, cotangent. In here, you guys see that we define those trig function based on the right triangle. Alright? It means that this angle theta right here is always an acute angle, which means it's less than 90 degrees. Now let's extend the concept a little bit more. See. What if I have a point P on the rectangular coordinates xy plane? This is y right here, 0 right here, x right here, and the point P is that x comma y. I'm just rewriting the definition using xy coordinates. So this is the distance from O to P, and I'm going to have a right triangle just like this one. And now the distance from origin to this point right here is x, right? And from here to here is y. And let's call this hypothesis R. Using the Pythagorean theorem, of course, we have r squared is equal to x squared plus y squared. Very similar to that one. Now, the trig functions are written this way. Sine of theta. Oh, by the way, this angle is still theta, alright? Opposite over hypotenuse, so y over r. Cosine of theta is adjacent over hypotenuse, x over r. And then tangent of theta is y over x. Cotangent of theta is x over y. Secant of theta is reciprocal cosine of r over x, and cosecant of theta is r over y. The reason why I try to bring it back to x, y, and r because I want you guys to think a little bit more than just a right triangle. What if you have a point P on the other quadrant, not just quadrant number 1, which means the angle theta right here may not be the acute angle all the time, maybe obtuse angles, or maybe bigger than 180, or maybe bigger than 270 degrees, and it still works. Okay? But before we get to there, see this. The x value gonna goes with cosine. The y coordinate gonna go with sine. Alright? So in the first quadrant right here, both values of x and y are positive. So what r, of course, is the radius. X squared plus y squared, so it's positive, right? So what? So, if p is on the first quadrant, so both sine and cosine will be positive because both x and y are positive. Okay? But now, what if you have a point P on this side? And this is your R, okay? Of course, if P is on quadrant number 2, then the y value is still positive, but the x value now is negative. You still have all 6 strict functions as before. However, this time, cosine, which is x, will be negative. Sine is still positive. Similarly, if your P is on quadrant number 3, now the angle is this big, okay? And what? Both x and y are negative. And that means both sine and cosine value will be negative as well. And of course, you can figure it out by similarity. If P is on the quadrant number 4, the angle is that big. And what? Cosine will be positive and sine will be negative. Do the same way. All right? So we develop a little bit more, not just talk about right triangle, but the trig function can be applied to any kind of angles. Okay? All right, let's move on. The main point that you guys care about for this appendix is the trig identity. And please try to practice some exercises that help you to learn the identity and it helps you to get to the problem faster. Okay, so let me erase this. I gave you the first one right here already. Sine squared plus cosine squared equal to 1. So let me write it up here. Cosine squared theta plus sine squared theta equal to 1. Okay? Move on to the others. Okay? Start from here. What if I divide both sides by cosine square? So I divide both sides by cosine square. And we have what? Cosine squared divided by cosine squared is 1. Sine over cosine is tangent. We just learned it a minute ago. Square. So this is plus tangent square theta. And then 1 over cosine is reciprocal of cosine, which is secant. So this is secant square theta. Now we have the second trig identity. Okay, derived from the first one. Similarly, instead of dividing both sides by cosine square, what if you divide both sides by sine square? And what? Cosine square divided by sine square, we're going to have cotangent square theta plus sine square over cosine, sine square over sine square is 1. And then 1 over sine square is cosecant square theta. You got the third formula. Okay? Those 3 formulas are the one that you guys are going to use very, very often in calculus. Okay? So knowing trigonometry is a must before we start calculus. Okay? Little trick in here is about even and odd function. I see this in the book, so let me bring it down here. The function of sine, the sine function is an odd function. It means sine of negative angle theta is equal to negative sine of theta. And recall back what it means by odd function. Pretty much say what? The graph will be symmetrical about the origin. Okay? And then the cosine function is an even function. And that means cosine of negative theta will be equal to cosine of theta. And by the way, an even function is a function that is symmetrical about the y-axis. Okay? Means what? You plug in negative angle or positive angles, give you the same value coming out. It's reciprocal. Symmetrical about the y-axis. Okay. Now let's move on to the set of the sum of 2 angle trig identity. So let's start with sine of A plus B. I'm using capital letters for the angle. So sine of the angle A plus B is equal to sine A cosine B plus sine B cosine A. Okay. Now, difference, sine of A minus B. You can think of minus B is A plus negative B. Okay, so what? Sine A times cosine of negative B. And you know what? Cosine of negative B is the same thing, that's cosine of B. And then minus here, sine B, cosine A. See why? Because that's plus sine of negative B. The sine of negative B is negative sine of B. That's why people write minus. So in other words, sine of the sum is equal to sum of subtract from sine A cosine B plus sine B cosine A. And then if you change the plus sign to minus sign, then you change the sign in the middle. That's how I tried to remember it when I first studied this. Okay, move on to cosine. Cosine of A plus B is cosine A cosine B minus sine A sine B. Be very careful. All right, guys. This is the for the cosine function, the sum of two angles is going to be a minus on the other side. And then, of course, the last one is cosine of A minus B. And guess what? This minus sign is going to change to plus. So cosine A cosine B plus sine A sine B. I don't know how people will remember all of those. In my experience, in my opinion, I just practice. I do a lot of exercises, and eventually you'll get it. And of course, if we don't get it the first time, that's very normal. Just practice a little bit more, and eventually you guys are going to get them. Okay, now we're going to talk about the double angle formulas. Sine of 2A is equal to 2 times sine A cosine A. Where does that formula come from? This one is coming from this one. Think of it. Sine of A plus B. Now think of sine of A plus A. You got what? Sine A cosine A plus another sine A cosine A. So 2 times. Okay? And what about cosine of 2A? Of course, it comes from here. See what? Cosine square of A minus sine square of A. And you know that sine square plus cosine square equal to 1. Therefore, we have 2 more versions. Cosine of 2A, same thing. It will be equal to 2 times cosine square of A minus 1. Right. You think of, you know what, cosine square plus sine square equal to 1, right? So negative sine square is cosine square minus 1. Add up here. You have this. And of course, the third one is this. 1 minus 2 times sine square of A. Okay? That's about the double angle for sine and cosine. What about tangent? Tangent of 2A is, oh, I forgot a tangent in here, so let me come back in here. Add more formulas. Tangent of A plus B is tangent of A, tangent, I just wrote the whole thing, plus tangent of B over 1 minus tangent A times tangent B. And of course, for the tangent of the difference of 2 angles, A minus B, you're going to change the sign, both top and the bottom. So tangent A minus tangent B over 1 plus tangent A times tangent B. Now we're okay to talk about double angle. Tangent of 2A, replace the B by A, so tangent of 2A is 2 times tangent A over 1 minus tangent square of A. Okay, and those are the formulas you guys are going to use quite often in Calc 1 and Calc 2, especially Calc 2, when you get to integrations sections. And it's going to come back very often. Alright, move on. The last set of trig identity. There's a lot of thousands of trig identities, and of course there's no way that we're going to cover all of them. In this session, I'll just go over the most basic ones that I believe you guys are going to use very often in our course. Next set of trig identity, only 3 more, is product of 2 trig function. All right. Start with the sine then. It's cosine is okay. Cosine of A times cosine of B. Product of 2 cosine function is 1/2 cosine of A plus B plus cosine of A minus B. Okay? Let me talk about this a little bit more. To be honest with you, this is not how I usually write when I learn trig. I try to honor the book, and I try to write the same way as the book wrote, so you guys can refer to it and learn better. But when I study, this is how I used to write. Cosine of A plus B plus cosine of A minus B is equal to 2 times cosine A cosine B. And this is pretty much the same, just less parentheses and no fraction. Right? It doesn't matter which way you write, it's really the same thing. Are we okay? So we're going to write this way, okay? Like our book. And what about sine A times sine B? It's going to be negative 1/2 of cosine A plus B minus cosine of A minus B. Okay? So product of cosines is 1/2 positive. Okay? Product of 2 sines is negative 1/2 of difference of